Hello everyone, this video is on linear equations, or solving linear equations as well is included. An algebraic equation is a mathematical sentence which indicates two expressions have the same value. So for here, 3x plus 7 equals x plus 11. 3x plus 7, we will sometimes say it's the left-hand side of the equation, and we abbreviate that to LHS, and x plus 11 is on the right-hand side of the equation, or RHS. Linear equations have the form ax plus b equals 0, where a and b are constants, a cannot equal 0, and x is the variable. The solutions of an equation are the values of the variable which make the equation true, so the value of x that makes this equal to each other. For any equation, the left-hand side must always equal the right-hand side. To maintain balance, whatever operation is being performed on one side, we have to perform to the other. So just show what that means is, here we have first example, part A, 5 is added to both sides of 2x minus 5 equals 7. So if we're adding 5 to this side, we have to add 5 to the other side. Minus 5 plus 5 equals 0, so we'll just be left with 2x equals 12. Part B, both sides of 3x minus 2 divided by 4 equals minus 1, and we want to multiply both sides by 4. So if we do that, once again you see I'm multiplying both sides by 4. By doing that, those two will cancel out, and we are left with 3x minus 2 equals negative 4. We use these ideas when we're solving linear equations. So to solve linear equations, perform inverse operations on both sides to isolate the variable. So the ideas of adding and multiplying, dividing, subtracting the same value to both sides apply here, but we normally do it in a much more streamlined way. With this one, we have 3x plus 7 equals 22. Another thing to remember when doing this is it's almost like we are undoing BODMAS, so we kind of work backwards with our order of operations. This example, we want to solve for x. We've got 3x plus 7 equals 22. When building this equation, the last thing that would have happened would have been the plus 7, so we need to move that to the other side. And we had plus 7 there, which means we need to minus 7. And really what I've done is minus 7 from both sides, which means we'd have 3x equals 15. Now we've got 3x equals 15. We've got 3 times x. We don't want 3 times x. We want to get rid of that. So to get rid of that, we have to divide by 3. So x will equal 5. Part B, 11 minus 5x equals 26. So the first thing with linear is we try to get rid of the constants that are added on minus to the x. So here we've got this 11. Now that 11 is positive, that negative after it is kind of attached to the 5x, so we'll just look at it's a positive 11. So to get rid of positive 11, we have to minus 11 from both sides. And we have minus 5x equals 15, so we have minus 5 times x. To get rid of times the minus 5, we have to divide by minus 5. So our x will equal negative 3. C. Same thing here, we've got x over 3 plus 2 equals negative 2. First thing we can get rid of is this plus 2. And obviously to get rid of plus 2, we need to minus 2 from both sides. So we'll end up with x over 3 equals negative 4. Now here we have x divided by 3, so to get rid of the divide by 3, we have to times by 3 to both sides. So x will equal negative 12. With D, we've got 4x plus 3 divided by 5 equals negative 2. Now because the 4x plus 3 is all divided by 5, we can't get rid of the plus 3 first because that's divided by 5 too. So what we need to do is actually get rid of the divide by 5 first, which we'll have to times by 5 to both sides. Now we've got rid of that divide by 5, we can get rid of the plus 3. So we're going to minus 3. And then we've got 4 times x, so we need to divide by 4. So our answer will be negative 13 over 4. E, we've got 5 times x plus 1 minus 2x equals negative 7. So here our problem is the brackets. So if we get rid of the brackets, we may find it all easy to rearrange. So we're going to have 5x plus 5 minus 2x equals negative 7. Simplify, so we've got 5x minus 2x, which will give us 3x plus 5 equals negative 7. And then from there, it's nice and easy. Next step, minus 5 from both sides. and then we can divide by 3. And our x value will be -4. With parts f and g, our aim is to put all the like terms on the same side of the equation. So we've got 5x plus 2 equals 3x minus 5. So we're going to put all the x's on one side and everything without an x on the other. So 5x, we've got positive 3x here on the right hand side, which means I need to make it a minus 3x on the other side. Then we've got minus 5 and we've got plus 2 now on that side, which means I need to minus 2. 5x minus 3x is 2x, minus 5 minus 2 is minus 7, and then we just divide by 2. So it's -7/2 or -3.5. G. The way to approach this is we want to get rid of our fractions first. Now, a really quick way is we can cross multiply. So it means we're going to multiply the 4 up to there and the 3 up to there. That will give us 3 multiplied by 2x plus 3 equals 4 multiplied by x minus 2. Then we can expand and solve. So we had 6x plus 9 equals 4x minus 8. Then just like part F, put everything with the x's on one side, everything without an x on the other. 6x minus 4x is 2x, minus 8 minus 9 is minus 17. Then divide both sides by 2, and our answer will be -17/2. Now, just some problem-solving questions you can encounter with linear equations. So the first one, the sum of 3 consecutive integers is 132. Find the smallest integer. So when we're looking at questions like this, we always need to remember to try and define our variables. So we're going to say let x be the smallest integer, because that's what we're trying to find. Now let's write an equation. So the sum of 3 integers. So that means they're adding. So we've got the smallest integer. Now the next integer is going to be the smallest integer plus 1. And the next integer that we add will be the smallest number plus 2. And we know that equals 132. Now from here we can just simplify and solve. So we're going to have x plus x plus x, which will be 3x. 1 plus 2 equals 3. And then we can just rearrange. So we're going to minus 3. Then divide by 3, which means x equals 43. So our smallest number was 43. Next example, if twice a number is subtracted from 11, the result is 4 more than the number. What is the number? So here, once again, we just need to define our variable and then make the equation. So I'm just going to say let x be the number. Now twice a number, so we want twice x, is subtracted from 11, so it'd be 11 minus 2x. The result, so that's equals 4 more than the number, so x plus 4. Now we just solve it. So take all the x's to one side and all the non-x's to the other. So we'd have 11 minus 4 equals x plus 2x. So it'd be 7 equals 3x. Divide by 3, so x equals 7/3. In the last example, cans of sardines are sold in 2 sizes. Small cans cost $2 each, large cans cost $3 each. If 15 cans of sardines were bought for a total of $38, how many small cans were bought? So wanting small cans, so I'm going to say let x be the number of small cans, which then means 15 minus x, because 15 cans in total minus the number of small cans. So 15 minus x is the number of large cans. Now we can make an equation. So we know that small cans are $2 each. So we want 2 times x. And large cans are $3 each. So that'd be 3 multiplied by 15 minus x. How many large cans we have? And that equals 38. And then we just expand and simplify. So 2x plus 45 minus 3x equals 38. Then we'll end up with minus x equals minus 7. So there x equals 7. So there were 7 small cans. And that is problem solving with some linear equations.